So it's with great pleasure that I get to introduce our next speaker. Christian Wheeler is the network planning engineer for the Indiana Gigapop, and as I announced yesterday, Christian is one of our new engineers. This is part of the iLight and Gigapop team. Christian has over 15 years of experience in networking. His most recent job before he came to IU was with Matrix Integration. And so I'm really excited to have Christian come up and talk to you a little bit about some of the things we've been doing at the Gigapop and the iLight upgrade. So welcome, Christian.
Yep, sure am. Thank you. Was there a different stage yesterday? It felt bigger from down there than it does from up here. Clicker. Wow, I'm going to stand over here where it's not shaking. Holy cow. I'm Christian Wheeler, network planning engineer for Indiana. Primarily with the Gigapop, but iLight. So I've heard a running theme lately, yesterday especially, about what's the difference between the Gigapop and iLight, and nobody knows what the difference is. And Marianne said it well yesterday as far as it's different routers. So it's the same team, right? I mean, the same engineering staff, we're all supporting both networks. So I thought I'd clear it up. The way I think of it is, it is different routers, but a better way to think of it is if you want to get connected within Indiana, that's iLight. If you want to get connected outside of Indiana,
it's got some weird robotic stuff in there. Let's get on the handheld.
we good? Are they ringing me? Hello. Okay. In connecting the outside world to the state of Indiana. So if you want to get from one side of the state to the other, you're talking about iLight. If you want to get outside, you're talking about the Gigapop. So I think that kind of helps people understand where those differences are. Like I said, from a day-to-day, we all sit in the same offices. We're all the same team. It's the same NOC folks who you're talking to when you have a trouble ticket. All that stuff's pretty much the same. From an architecture perspective, it is separate. We do design them separately. You know, it's not in name only, but from a people perspective, it's very much the same thing. So, agenda. Me, I'm going to kind of tell you a little bit about myself because I'm new and most people have been around for quite a while, and so it's good to kind of get an idea of who I am. We'll talk about some usage statistics as well as some architecture. I think iLight and Gigapop are a bit of a black box to a lot of people. So, and there's, you know, I'm not AT&T, so there's no secret magic that I have to hide from my customers about how our network is designed. So I think it'll be good to kind of let you guys see a little bit of how that is. And, you know, feel free to ask questions about it. I would much rather do Q&A than talk at you and go through slides. And I only have 187 slides, so it'll be quick. Nobody thinks she knows I'm joking. 100 gig bigger, faster, more intense. That's the upgrade. We've done a significant amount of upgrades to both Gigapop and iLight, which are still ongoing, but both of them have had quite a bit, and it's all about that 100 gig, right? More and more and more and more. And then services. So something that Heather Stark, who's also, we actually started the same day. She's right there. She's amazing. If you ever need anything, get a hold of her. She's in charge of outreach and education. And there's a lot more than just connecting to a network and getting it lit up and going places. There's a lot more to iLight than just that. So I think touching on a few of those things may help you kind of say, oh, wow, we didn't know you did that. And there's definitely a lot more. It's not comprehensive, but it at least starts the conversation. All right, so me, I'm Christian Wheeler. I just started in January, beginning of the year. I worked for Matrix for 6 years prior to that as a network guy, and then I lived in Illinois before that. Almost born and raised in Illinois. I spent some years in Switzerland as a little boy, but I studied philosophy primarily in college. So everybody says, how did you get into IT? Well, philosophy, you know, a lot of people sort of say the more science is figured out, the less philosophy has to do. And there's a little bit of truth to that, but definitely in a world trying to compete for research dollars and find practical applications, AI has been a big push, philosophy of mind, epistemology, how do we know things. So I worked on an early, it's kind of laughable when I look at it now, AI project called the Protothinker project, and it was about semantics and building a program to diagram sentences and build meaning out of those, so nouns, verbs, adjectives, and what those nouns, verbs, and try and get some meaning out of it. Then I graduated and I was not doing much particularly, and I had a kid on the way, and I said, I have a philosophy degree, which will make me about $8 an hour, and I need to figure out something else. So I started web developing in the .com days, and then slowly migrated over to more of a systems role. I've been working with integrators for almost 20 years, like Matrix, and specializing in networking for the last 10 to 15 years. I've got a very strong server background, though, as well. Microsoft certified, FreeBSD, server admin. So I have this sort of wider breadth than maybe some guys traditionally in my position have. I've done lots of wireless, and not just that service provider world. So a little bit more breadth. And then specifically networking for the last 10 to 15 years, Cisco, HP, Juniper, firewalls, that kind of stuff. Most of my consulting career has been with higher ed people. Matrix is very higher ed and focused, but my previous company before that in Illinois also was. So it was always an area that I preferred to work in. I think it's the hardest of environments. I've worked with financial, healthcare, all of those different verticals, but higher ed, you're an internet service provider to your dorms, you're doing very niche needs with research computing. Then you have the campus side. You have a traditional enterprise business needs, just like any other corporation. And then on top of that, you don't get to own any of the endpoints, and you have very little control over what they can do on the internet. It makes for a very challenging environment, I think, but it's fun. People keep coming to, when I worked at Matrix, what are people doing for this? What are BYOD, that big buzzword, bring your own device. What are people? I said, well, universities have been doing it since the 80s, since there were networks to connect to, they've been dealing with BYOD. So it's not the great, scary thing that everybody thinks it is, because we've been working with it. The other thing I like in higher ed, in the corporate world, you'll have 100 users to an IT staff member. I mean, I don't even know the numbers at any of your organizations, but even the most well-funded universities, it's not even close to that. It's probably 500 or worse to 1. So again, creates a lot of challenges as far as management, design simplicity, stuff like that. So I really learned to love the higher ed. So when I heard about this position, I was very excited about it and jumped right away. So, design. This does not show up well at all, and I apologize. If you guys want to see this, I'd be happy to send it out, but this is sort of a logical overview of Gigapop. So I forgoed doing much discussion on iLight because iLight is 2 routers with a bunch of switches that you guys connect to. So from a network diagram perspective, it looks a lot like a redundant core campus network. It's not terribly exciting or complex. It's pretty easy to articulate. But the Gigapop, I think, is a little bit more of a mystery to people. So this area here is really sort of the logical setup. These are our two core MX960s, Juniper MX960s, and they exist, one at the IUPUI campus and one at Henry Street Lifeline Data Center in downtown Indy, so they're both in downtown Indy. Then they connect up to Chicago via a 200 gig lag, so two 100 gig Ethernet circuits. And then these connect to the various locations in Chicago for different needs, be it connecting with the CIC. Everybody know what the CIC is? Besides us, the CIC is a Committee for Intercollegiate Cooperation. Basically, a bunch of the Big Ten schools and some others got together to create an infrastructure that they can all share to connect with each other as well as outside organizations. We benefit tremendously. We as a group benefit tremendously because of that CIC relationship. First of all, we can directly connect, and most of these are universities. I wish this resolved much better. It's way too blurry, but as far as other regional networks and other universities, be it University of Illinois, Michigan, WisCnet, which is Wisconsin's regional network, a whole variety, as well as ESNet. Anybody familiar with ESNet? They provide connection within the LHC. Everybody's heard of the LHC, right, and CERN. So the Large Hadron Collider, they're creating black holes and trying to blow up the world. That is a tremendous amount of our research data needs coming from our members today. Tremendous amount of bandwidth. And all of that really is brought at a much more affordable level because we can share this infrastructure with all of these other schools. It's really a godsend in that regard, as well as one of our internet connections goes through there, and again, we pool the resources, we get a much faster connection than we could typically afford. Again, so there's iLight, ENA, Indiana Office of Technology, University of Notre Dame. These are all dual homed at various speeds. The speeds, the colors represent the speed, so you can see 1 gig, 10 gig, 20 gig, 100 gig, 200 gig, and then there's a 100 gig fiber connection that these are all shared across.
Christian, these maps are on the website.
Yes, yeah. And this one, it is a high resolution image, but you know, it's done through OmniGraffle, the mapping, but for some reason the display isn't showing it up. And it just gives you an idea of how things are connected and what all organizations we are connected to. So there's a lot more than just, you know, the universities within iLight, because it gives you a lot of opportunities to share data across other networks, including other regional networks, and leverage these sort of, like the astronomy folks, a consortium that lets us leverage a lot of expensive stuff for much less money. This down here is our fiber infrastructure. Obviously, compared to iLight, it's nominal, right? Because we only go really a couple of places. So this is the IU data center in Bloomington, which has these two HP 5400 switches that then connect to these two Juniper routers, which are these guys, right? And then they have, via the IUPUI campus at University Library, this fiber goes all the way up to Chicago through Frankfurt and Walcott, and I forget what CRPT stands for, and 111 Canal in Chicago, all the way up to 600 West. You know, that's all the CERMAC and all of that. And that's that 200 gig connection. So currently, if you look, we have, and this needs to be updated with Notre Dame. Notre Dame just added a 100 gig connection direct for their research and education, LHC. IU has a 100 gig connection, and then Purdue also has a 100 gig connection. And that's all research-driven data. And you'll see that data follows a much different traffic pattern than, say, obviously the campus data. It doesn't follow the same time of year cycles that some of the other stuff does, right? I mean, you'll see the drop-off during this summer is precipitous with our internet traffic, but if you look at Internet 2, or it doesn't really have that same traffic pattern. So people say, oh, it gets easy in the summer. Anybody who knows the real education world realizes it's actually a lot busier and rougher in the summer, right? And if there's any questions about this design, I know that it's not necessarily been obvious to people how we're all set up. So if you guys have questions, please interrupt me, or you can ask me another time, but don't hesitate. I welcome the questions. Internet providers that we have today. So our primary, I'll start at the bottom because most of our traffic goes through what's called the content peering services within Internet 2. So we have 200 gig connections to Internet 2, and as part of that, we get 20 gigs of commodity internet on this TRCPS, Transit Rail. That is not a full IP4 and IP6 routing table, so it doesn't take care of the entire internet, but about 90% of our traffic goes through there. So anytime, I feel like I'm getting two mics now. Anytime we get the routes here, we're always gonna prefer it. Significant cost savings compared to standard, commodity internet. Telia is our second and would be our primary commercial carrier, and this is the one that we connect to up here via the CIC. And this is a perfect example. So that's actually a 100 gigabit connection, and it's unpoliced at this point. So we, as the CIC, have shared this bandwidth, and Telia has given a 100 gig interface connection. Now, we use less than 10 gig. However, in the event of a DDoS attack or something like that, we can burst well beyond that and not receive an outage. That's a big deal considering we're having members get DDoS regularly, and we're seeing it in some of the networks that we support in other states. So not to get in the scare mode of yesterday, but it is an ongoing thing for us and our members every day. And so the fatter we can make that pipe, especially in an emergency scenario, so we're not paying for 100 gig or an 80 gig, but if things were to hit the fan, we'll still be able to utilize that internet connection. Zayo, currently we're the one in Indianapolis, we just lit this up, and we're using that purely for a backup at this point. But it is, the full IPv4 and v6 route tables, which is about 600,000 routes. And then the Cogent is the same. We're actually using this for traffic outside of Indy that, it has a shorter path than going up to Chicago. And again, but really we're talking about nearly 20 gig of 16 to 18 gig of sustained traffic fairly regularly on this, and 2 to 3 on this. So it's a significant amount of it is all going on here. The other thing that's great is it gives us a lot of geographic diversity because of Chicago and Atlanta, and we're also in Indy, so we've really got major, if you look at any fiber plan for the country, everything's going across Chicago in the north and down through Atlanta and Texas in the south. So we've got these great diverse paths for redundancy. Caching, so someone asked me actually what this was, and I kind of had always gone under the assumption that everybody knew what we were doing with caching and that kind of thing. If you go to Google, and anyone's been to Google, if you go to YouTube and watch a video and anybody else has watched that same video, chances are you're not using your internet bandwidth. You're just using your standard iLight bandwidth. We've got a whole bunch of servers that Google owns that we peer with over a 10 gig connection, and it caches info so that way we can save on commodity. Netflix is the same way. There's a big red box, that weird Netflix red on it, and that downloads it, and we've got a 20 gigs of connection to that box. And if you go, you could see when the House of Cards season came up, you could literally see the traffic patterns immediately change. So Netflix, I know people say, oh, it takes up 30% of the internet. not 30% of our network traffic. It's a lot more. And we always kind of joke, you know, research and education, but everybody really just wants to watch Netflix, right? And it's not really true. The research and education traffic is so heavy now. I mean, just like what they were talking about, it's so data driven, and there's so much of it. It's shocking, actually. But so this is again another added feature that iLight's brought in, or Gigapop's brought in to reduce the amount of commodities. So when you're paying for, I have a gig of iLight and I have 500 megs of commodity, what does that mean? Well, it means you can save with your Netflix users, with your YouTube users and Gmail, and you know, obviously if you download a new video, it's new, right? We all know how proxy servers and caching servers work. Akamai is a third-party content delivery network for Yahoo uses them a whole bunch. They're the largest, and they have a whole rack of servers, like a 42U rack of servers in our data center that all they do is cache stuff, so we don't have to go out to the internet for it. And then Apple's CDN. So this is not content cached, but it is a direct peering. So again, you're not going across our Telia connection. You're not eating up internet bandwidth that you paid for the latest 9.2.3 or whatever it is that just got shoved down my throat. So there's definitely more that we're planning. It's a slow process, and some of these companies want just ridiculous amounts of money. Microsoft wants a ridiculous amount of money for this type of service. So it's just one of those things where we are going to increase it. Facebook is a likely candidate coming up soon. Microsoft would be great. They're just very expensive as usual. So that's a big step to saving, obviously, a ton of commodity internet bandwidth. Any questions?
About the caching, like one of the schools out of Penryn, Paschy is a conglomerate of other higher eds. They have a dedicated 1 gig just for caching because their students do a 1 gig traffic of nothing but Netflix. And that's all we send to them is caching services on that. So this saves a lot. If you go back to not doing us or somewhere else, that you will see your internet bandwidth goes way up the roof, and you're going to have another connection just to handle that caching stuff that could be offloaded inside the network.
Yeah, I mean, we've seen stats where over a month, depending on, it obviously varies, but where during that month, Netflix was 70% of the internet traffic. Of like, not, you know, Internet 2, RNE wasn't just internet, but it was 70%. So that month, people saved 70% on their bill as far as, you know, I don't know anybody who wouldn't have needed to increase their commodity without something like that. So it is a huge benefit, it really is. I know the Google, we're hitting that server at 10 gig interface at max regularly. So that one's definitely a big one. YouTube obviously is high def as well now, so it's quite a big source of data. Okay, so here's some traffic. This is the year of 2015. And that's why I say you can obviously see traffic trends jump out right away. Green is inbound, so stuff coming from the internet to us. And this is purely just internet. But you can see right here, there's summer. And you can see right after the winter break, nobody's studying, right? Everybody's just watching Netflix and YouTube. But that drops off rather significantly towards the spring where you've got finals. I mean, it's that predictable, right? But what we averaged, inbound internet, was 7.35 gig. Max burst we hit. Now, these are one-day averages. So it could have hit higher than that, but that one-day average max was 16.89. Outbound, you know, obviously with the internet, you're rarely sending out more than you're bringing in. This year, to date, so this is as of Wednesday, average 12.3 gigs, max 25. And you can see that same, here's December, But what happened here, nobody was doing anything during finals time. I think that's hilarious. That's definitely new. But you can see outbound is pretty flat. And then we've obviously dropped off. Here's May, right? Now, what I find significant is the number differences. So in 1 year, the average utilization has grown 67%. Year over year, that's crazy. That's a huge amount of traffic increase. Peak utilization, that's good for planning purposes, but from a trending perspective, I want to be able to handle my peaks, but from a trending perspective, and still a quarter more outbound. So still a significant amount, but not a symmetric increase. So that tells me more video and higher def video. Netflix is doing 4K video now. YouTube is doing 1080p, 60 frames. That's what that is. Here's Internet 2. See, and now this is mostly research and education, right? This is not the TRCPS. So even though that's Internet 2, that still counts as internet traffic, right? So this is purely Internet 2 RNE, and you can see it does not, that's that same 1 year time frame, and it does not have that drop off that everybody thinks. Oh, well, those physicists are still trying to ruin the world, right? They're still trying to blow us up, and I don't know what this dip is, but there's actually an anomaly that I took out because it was so anomalous. There was a sustained 1 day of 50 gigs nonstop. So we were sending data to Internet 2 at 50 gigs for a whole day. It's just an insane amount of data. But it was so anomalous, I didn't want it to fall in with my averages because that's not something I'm going to be trending on, But if you look, our average is 9.5. Max we're hitting is just under 18. And then you look at this year, and again, that huge jump in numbers. And you can see, again, it just doesn't follow that same trending. It's much more consistent. We have a dip right towards the end of the year, but it's already starting to go back up as the physicists get back to work, right? And not just physicists, but they're the ones with, researchers. They're the ones with really huge data sets, although there's others as well. But so that's another, more than a third, almost a 40% growth in average utilization. Hardly any outbound growth, but a huge inbound. Why? Because these guys are pulling, especially with LHC, they're pulling these data sets from the LHC. So the LHC kind of works on a tiered program, right? You have tier 0, which is CERN. Then you have tier 1 organization here in America that replicates data, and then they replicate the cache servers that are at tier 2 organizations, which I believe IU is one, and then those replicate to tier 3. So you can see that it's pulling down these huge chunks of data and then crunching them in their computer clusters. And then caching. So I thought it was useful to see how much impact the cachings had on our internet and how we're using it. So this is 2000. Oops, I mislabeled. So that's 2015. That's a mislabel. And you can see we're average, this is all the caching, 4 gigs. And of course, you can definitely see that, you know what, no one's in school. We're not watching Netflix like we were. And then you can see we've doubled it. We got almost 100% growth in average utilization. So our internet usage has grown about 70%, and our caching has grown beyond that. That's a good sign because, one, that means it's growing beyond our pace of our internet usage, so it's actually, we're doing more optimization, right? We're caching more locally, and that's actually saving everybody more money. It saves iLight and Gigapop, right? The less you guys have to go all the way out to the internet to get the data, the less those pipes get filled. So it's definitely a good trend to see. I'd like to see it increase even more than that. So bigger, faster, more intense. So who's Star Wars fans? I'm a big Star Wars fan. I'm a big sci-fi geek. They used to make fun of George Lucas because the only direction he ever gave his actors with bigger, faster, more intense. So during the first filming, he lost his voice. They gave him 3 cards. One said bigger, one said faster, and one said more intense. So that's all he needed to do to direct the films. So I thought it was appropriate for the Gigapop, because that's really, I mean, that's I suppose what all network upgrades are about, but it's really, it's all 3. It's not just a faster network. It's more in a lot more ways than just that. So I kind of wanted to go over it at a high level. I'm sure there's lots of questions about what it really is in the underneath, and I'd love to ask or answer those questions. So feel free to interrupt me as we go, or grab me aside if you think of it later. Objectives. So one was high capacity backbone, right? We needed more bandwidth. You guys need more bandwidth. It's growing fast. The needs are growing faster and faster. There's NSF grants out there for these research grants for increasing bandwidth. Things like the LHC are increasing those needs, and just getting that higher density growth for today to meet what you guys are asking of us today, as well as making sure we can scale in the future. Enhance resilience and speed to recovery. So today or yesterday's network doesn't recover as fast as we would like. It's not as resilient as we would like. And a lot of this upgrade is about making that happen. Allow iLight to offer new and enhanced Layer 2 and Layer 3 services. So, and I'll get into the architecture of the old iLight and how that kind of limits us in certain ways as far as what type of services we can offer, and how the new one gives us some more flexibility. And this is a big one: simplify and automate management and troubleshooting. iLight and Gigapop are just like you guys in that we're all understaffed, right? I mean, it's the world of higher ed. It's the world of any IT department, except for the most well-funded corporate ones. And so being able to simplify tasks, not have to get low-level CLI on everything that we need to do, as well as automate some of those tasks is a huge thing for us to be able to speed recovery, but also speed delivery of new services to our members. So the first one, enable a high-capacity backbone. 100 gigabit backbone was the minimum, right? That's what we were looking at. We wanted to have a 100 gigabit backbone at minimum. And that sounds like a tremendous amount, but how many people in here have 1 gig connections to iLight? So there's 4, 5, 6, 7, 8, 9, 10, 11. How many have 10 gig? 1, 2, 3, 4, 5. We've just eaten most of that 100 gig right there. Right? I mean, it's not a lot of bandwidth anymore. It's crazy that it's not, but it's not. So we needed something that would be a minimum 100 gig backbone, but would scale. And a DWDM, if you're familiar, all that means is when I light that wave, it's a specific wavelength. And then I can use the same fiber and light up another wavelength and add more bandwidth to it without having to lay new fiber. We can get up to 3.2 terabits on existing fiber. So we can grow to 3,200 gig. And today, we're at 200 gig on the North Ring, and when we're done with the upgrade, we'll be at 100 gig on the South Ring. Now, but that 32 terabits allowed us to light up 100 gig for Notre Dame research right away and not impact the rest of the network. So that is a completely third 100 gig on the North Ring that doesn't impact anybody else. Separate wavelength in that DWDM, dense wave division multiplexing. And OTN, you guys familiar with SONET, right? The old OC3s, OC12s, remember those? OTN is the new SONET. It's just bigger. SONET was based on a 155 megabit container of data. This is based on a 1.25 gig. It's just better to scale to the needs of today. It matches better with Ethernet than SONET did, but it's an optical networking protocol for metro Ethernet networks. Optical Transport Network, I think OTN stands for. Any questions on that? nobody is generally, most network guys aren't really all that comfortable in the long-haul optical world, and Lord knows I wasn't. So it seems like a bit of voodoo. An important thing to note here is the way iLight was yesterday is we had this big wave of light go around the ring, and at every single pop, all that traffic would be brought down from optical to electrical through a switch, back up, and if that was your pop, traffic was dropped off, and then back up to optical, and then back across the ring. That creates a lot of latency, although some people would disagree with me on that, but it does. I'm right. As well as, that means everybody's traffic gets dropped at every location and then picked back up again. That's not optimal, right? What we want to do is bring your traffic in, drop it off to you, but everybody else just swings around the ring at light speed as normal. That's one of the things that this new system gives us. The other thing that it does with OTN is your connection is not only isolated at layer 2 with VLANs and like it was yesterday, but it's essentially isolated at layer 1, at the OTN layer, at the optical layer, because it's in these buckets, just like a OC 12 was carved out of a larger OC 192, and those were all separate. It's all separate. You can't eat up too much bandwidth and step on his bandwidth because they're at layer 1 separated. The security side of that's there too, of course, but it was there, the security side was there before as far as through VLANs we're separating things, but now we're doing it at layer 2 or at layer 1 as well. Enhanced resilience and speed to recovery. Who likes spanning tree? You like spanning tree? You're the one person on the planet. No, I like spanning tree. At Matrix, I spent my 6 years evangelizing spanning tree. You need to use it. Doesn't work. Yes, it works. You need to use it. No. It does work, and it's a great protocol because it's been around since 1982, and it still works, right? I mean, it's still used. However, for a Metro Ethernet network, it's not the right tool for the job. And today, until we're finished with the network, that's what we've got from a protection protocol. So the way iLight recovers from a link going down and sending your traffic the other way is the same way if you had a closet switch with dual uplinks to 2 cores, one would be blocking with spanning tree, and if that went down, you'd use the other. That's at best a 6 to 10 second delay. That's just not good enough, right? Especially when we're talking about research and education data that's being blasted, 40 gigs at very small packet size at very high rates. It's just not voice, these kinds of things, it's just not okay. G8032, oops. It is a layer 2 ring protection protocol. So it's like spanning tree, but better. It works in a lot of ways the same as spanning tree. It's a loop prevention, but it's sub-second. In fact, it's around 10 milliseconds. So you won't even miss a ping. I mean, it's faster than you could test it, the failover occurs. OTN offers enhanced FEC, forward error correction. So in Ethernet, if you look at an Ethernet frame, there's no information about how the data is, right? I mean, if we look at interfaces, we can see CRC errors and things like, but that's all stuff that's done after the fact to try and see if the packets came in good shape. There's no actual inherent troubleshooting within Ethernet. There's no data in there that says anything about what quality the link is. And there's no data in there that would allow us to fix anything if it's got bit errors. And remember, when we're talking about with optical and at these bandwidths, it's very high rate, very fast, and we're talking about microseconds. Forward error correction can identify errors and at the receiving end fix them. Not everything, they always over-tout these things, right? Oh, it'll fix your problems and you'll wake up and there'll have been a bunch of alarms and then you woke up in the morning and they were already cleared because magic, right? No, but it's absolutely much more resilient to errors within it. So if there's errors within the fiber and it's not enough to cause a link failure, but it's enough to cause a link problem, which is far worse in my opinion because it's harder to troubleshoot, this can, within certain tolerances, fix those ones and zeros that get mangled along the way. That's very good. Enhanced diagnostic tools for better troubleshooting and diagnostics. OTN, along with Sienna, the product that we've purchased for this, it gives us an end-to-end OAM, operation, administration, and management. So it's an end-to-end view of the network where we can, and seeing how it all looks, how the traffic is being handled, and is it being handled, you know, are packets getting dropped, are ones and zeros getting mangled in transit, and we can see that in a much quicker way and in a more comprehensive way rather than just looking at one segment or one link, right? I mean, if you've ever, it's very tough, in my opinion, when you're looking at, oh, I gotta look at this interface and this interface and this interface, and I've gone through 10 switches and 14 interfaces, and now I don't remember what and how it all fit together, and then you get a piece of paper, and I mean, that's how I troubleshoot spanning tree, right? I literally get a piece of, I felt good because Damon was doing it one day, and he got out a piece of paper and was drawing it out, and yeah, because you can't, it's very difficult to aggregate all that stuff into an overall picture. Well, that's what that gives. That's fundamental to OTN, and it's fundamental to the Sienna product line. Allow iLight to deliver new and enhanced layer 2 and 3 services to members. So site-to-site layer 2 tunneling. So we have members with multiple campuses, and they want to be able to extend a VLAN across to both campuses in order to replicate VMs, say. They want to have a DR site at the other side. Today, that's very difficult for us to do. We've got some one-offs that are configured that way, and in general, when people say that, I say, well, what VLAN do you want to replicate? I'll be happy to transit it as long as it doesn't overlap with one of our VLANs. Well, that's a pretty severe limitation, right? There's 4,096 VLANs, and some people have hundreds of VLANs, and we've got 75 iLight members. The math doesn't work out, right? We're going to run out of VLANs, and suddenly you're going to say, well, wait a minute, all my servers are on VLAN 70, and you're using VLAN 70. Now, I can't just readdress all my servers to a new VLAN in order to get this project done. Well, now we can actually extend that layer 2 infrastructure across sites much more easily and without a care of what your VLAN numbers are. It's no longer it essentially be invisible to us. Traffic isolation, like I said, the OTN gives us a much better handle on traffic isolation because it's happening at layer 1, right? It's not happening at layer 2 or layer 3 through VLANs or subnet. It's happening at layer 1 instead. That's a fundamental thing, right? That's before any of your protocols get involved, right? So one, trying to do VLAN hopping, which is an attacker, a hacker thing where you try and hop from one VLAN to the other and pretend like you're on a different, those types of things, well, there's no layer 2 protocol to fake out, right? So it's a much more secure, but also at layer 1, your traffic is being managed from a bandwidth perspective, which allows us to police that bandwidth much more efficiently, which is something that we've struggled with today. I'll let the cat out of the bag. When you guys are getting policed with bandwidth, we struggle really policing that because of the limitations of the hardware. So there's some ways you could get around it. It wouldn't do you much good, but it is something that we struggle with. And in the old architecture, if someone ate up all of the bandwidth, then everybody else was miserable. This prevents that because we can containerize your connection, and it's a 10 gig connection, and it can never go outside of that 10 gig. Doesn't matter what your interface is, physical interface. If it's a 1 gig connection, it's 1 gig. It may be a 10 gig interface on your switch or your router, but it's a 1 gig connection and you can't grow beyond that. Layer 3 peering, obviously we do layer 3 peering with people today. This is something we'd like to expand on the nature and way we do it, and I'll talk about that in the service section a little bit. But essentially, there's benefits of BGP peering, there's benefits of these things, but there's a lot of organizations that don't have the expertise or infrastructure to do it in-house. Something we want to help with. It helps us, it helps our members. It's definitely a big advantage. Simplify and automate. Point and click provisioning. We can say this endpoint here in Fort Wayne, and we want them to be able to go all the way down to Indy, source, destination, click, provision. All on a map. Rather than going, okay, I got to go to Fort Wayne, and then, okay, what's the switch next? And then the backwards path is over by South Bend, and configuring every single switch and router in between, as well as the optical gear. It's all just a point and click. End-to-end OAM, like I said, operation, administration, management. It's a great buzzword that industry folks love, but it's actually real. So, and with converged optical and packet, I want to go to this first because it explains why we can do end-to-end. So traditionally, you have two networking worlds, right? Optical, and then it gets changed into switched, our world, right? Layer 2, layer 3, Ethernet, all of that. But optical has optical is, there are no packets, right? It's a stream of data, 125 milliseconds, or microseconds long, or milliseconds, sorry. It's a completely different paradigm. So what you end up having to do is you get this big optical gear, and then you plug in a switch to it, and then you do all your switching here, and then you do that at every site. The Ciena platform that we've got is what they call converged optical. So that means you plug straight into the Ciena, and you get your layer 2 Ethernet connection, which then within the box gets sent up into that ODU, OTN 100 gig that then goes out to and it's an end-to-end solution on one device or one set of devices. Simplifies management, but it also allows us to have that sort of end-to-end OAM. Now there are going to be sites where we have to have a switch. We got 12 1 gig people in that hanging off that one pot. That would be insanely expensive to terminate all of them into the Ciena gear as opposed to a switch and just. But in most cases, you're going to end up straight into that Ciena gear, and we're going to bypass any traditional. I mean, it is a switch. The box is a switch in the traditional sense. Fewer panes of management. How many people have heard the sales pitch about a single pane of management? There's no single pane of management, right? There's lots of single panes of management, but I've never seen anyone succeed at that. So that's why I say fewer panes of management, just fewer stuff that we have to look into that's disparate systems, right? Today we'll have that. We have to get the CLI of an EX4200 Juniper on the premise, and we've got the ONS 15454 Cisco Optical that then goes to the next site, which is another 15454. All of these have their different separate management interfaces. So this gives us one management interface for the entire Ciena platform. All of them are in there. They're all the alarming, all the monitoring, all the provisioning, it's all one pane. We don't have the 4200 at the customer site anymore because we've got this sort of converged system. And then we're really talking about we've got Cienas and our two MX960s in the core. Drastically simplifies management and troubleshooting. Services. So this is where I definitely want to say call Heather Stark. If you want to know if we will do it, call her. She'll say yes. She'll drag me out to your campus and we'll do whatever it is you want and we'll have fun. That's sort of the short answer. There's so much that we do that people don't know about and don't take advantage of. Some do, but that if in doubt, get a hold of Heather Stark. Extremely responsive, extremely useful person to know. And I love it when we go out on site. It's just a lot of fun to go out and see you guys and talk about your networks and figure out the things that we can do. We have anything from, we've had universities who are doing VoIP and asking our advice on their VoIP implementation project. I am not a VoIP guy. I've designed hundreds of networks with VoIP that runs on it, so I can help. And that's free, right? That's something we want to do as members, that we help each other. So that's a good example, is those network design advice, advanced layer 2 and layer 3. BGP and IPv6, we get a lot of, hey, we hear about this IPv6 thing, it's real new, and they ratified it like 15 years ago and are still not using it. We can give you IPv6 address. We can give you millions of IPv6 addresses, quintillions of IPv, literally. So, and we're happy to set up IPv6 peering and help you guys figure out the routing and stuff. If you've got Microsoft machines on your network, by the way, you've got IPv6 running on your network, and it's probably bad. So, lots of multicast that doesn't get handled right. So it is something that we can help with. BGP, like I said, I liken BGP to being the master of your own destiny when it comes to the internet. There's so many features of the internet that you can take advantage of when you're peering with your providers. Redundancy, independence, owning your own IP space, not being tied to a vendor. We have lots of members who have a second commercial vendor that they use, and if they own their own IP space, they could have inbound and outbound redundant internet using BGP, but it's not like any other protocol that you use within the campus, and people get very gun shy about it, and it's more of a service provider skill set or really large enterprise skill set, and so we can definitely help with that. And BGP black hole service, I love this. If you have BGP with us, peering, you can add to your route what's called a community string. It's just a string, literally a string variable. What does it do for you? If you're getting DDoS'd, and so we have big enough pipes at the Gigapop where most people can get DDoS'd and we don't notice it. That's great for us, but it's not great for you guys, right? IU, as big as they are, gets DDoS attacks, and we don't even know it until they tell us. Now, they have been awesome and worked with us extensively to build filters that we are now going to be rolling out to the entire community, meaning all of our routers, to prevent it. And it's without spending a dime, it's the 90% solution. I mean, it gets a lot of attacks. And it's been field tested over a big, fat, juicy target like IU for a good year now. It's really we're really lucky to have had that resource. But if you are getting DDoS'd and you've got a server or a user that's getting 10 gigs of data flooded to them, which in today's day and age is not a large DDoS attack, that's flooding your internet pipe. So even though one device, I mean, in some cases these have been Xboxes and wireless phones. You don't care about the device, but your whole network is dead. You can send a BGP community string that says this one route, /32, one device, black hole it. That tells our routers, black hole that traffic, and then we send it on upstream to the internet providers and say, black hole it. And within a few minutes, it's automatic from the moment you do it on up, that traffic's getting blocked at the provider, and it's never even hitting Gigapop or iLight, let alone you guys. So that's a big deal, right? I mean, that's sort of like what some of these other cloud-based services are. Now, we don't scrub the data. We are adamant at Gigapop, we don't get in the way of packets. We don't have firewalls, we don't have packet filters, we don't have bandwidth shapers, we don't have web filters or IDS, IPS at all, let alone inline. We push packets, right? That's what we want to do. So, but this allows us to say, hey, our members are crying foul, they need big time help, and we can automatically mitigate it until things, wagons can get circled and things can get figured out. So if you're not BGP peering, this is my favorite reason why. And if you're not doing it because of the technical hurdle of figuring out how to do it, we'll help you get it set up. I mean, we'd love to do that. It helps us and it helps you, and it's not nearly as difficult. Now, people say, well, I need a big, huge mega router that's going to cost 50 grand. No, you don't, because we're just going to send you a default route. So you don't need a 600,000 route table. You just need one, which is not going to eat up any router. So it's really not the barrier, I think, that a lot of our members think it is. So if you're not doing it today and you're interested, please, Heather Stark. starkh@iu.edu. I should have put that. Starks. H Stark. Oh, see, by the way, my email is WHEELECB. Yeah. So you're going to put the R on there because it's Wheeler, but they won't put the R on there because my email address is like one letter away from Brad Wheeler's email address if you do that. I don't want his emails and he doesn't want my emails. So, questions? I have no idea where we are on time, so. Oh, we are? I'm sorry. So, yeah, go ahead.
The Gigapop caching thing. So, oh yeah, that's right. Everybody knows what Netflix and Google do, right? Everybody knows what the services they offer, but Akamai doesn't have any content of their own that we're going out to get. But their customers, if you go to their website and look through the customers that they have, well, I took a small list real quick to make sure I could go through a couple of them. Adobe, IBM, the NBA, National Basketball Association, Red Hat, Ubisoft, NBC with the Olympics coming up. They have all of their content cached. So any of that stuff that you might be trying to stream or that your students or faculty and staff are trying to stream, they're going back to get them from our cache servers, which is, I think if I'm reading the database right, is by far and large our biggest section of cache servers.
Oh,
they have
yeah.
like 18 servers where Netflix has 3 and Google has 2.
Yeah.
Yeah.
So
it's
we have a full rack of Akamai servers. I mean, the whole rack is full of them. And it's what they call a content delivery network, right? So they just have these caches sitting all over the place, and then they replicate their traffic just to multiplex it, right? Just to make it so they're not. And then they're the largest CDN in the world that I'm aware of. So they don't produce any content themselves, but guaranteed you're getting data off your caching, and it's everybody you can think of just about. So if you bought Destiny and downloaded Destiny to play on yours through Steam, you got it through Akamai likely. And that's good because that's a huge install file. So,
The Adobe files, downloading those Adobe files. Sorry. I just didn't know if it was turned up. But like just downloading the Dreamweaver install files or the constant Adobe updates that you get every day, it's their most popular content, so they're cached right there in Indy where they're coming straight to you through that.
Yep. Go ahead. Sorry, I'll let someone else pick.
I'm curious if there's plans to provide the more granular data, trending data to your members as well, because that's a challenge that for us to maintain right-sized pipes if we don't know how the data is being sliced and diced. And up to now, I've been told that all we get is snapshot views.
Oh, no, you know what, we should discuss it in detail, but if any of you are echoing that sentiment, just please talk to us. So Snap is a view that you can go to, and it's a web page that you can go to and you can get a view of what your traffic is. You can set a date range on that, it's inbound. These
Familiar with Snap.
These are Snap views.
Right, I understand, but you have views into what's I2 traffic, what's commodity.
Yes.
We don't have that.
So we can get you your I2, your commodity versus everything else.
I know.
And
it's always been a snapshot. Well, right now you're using 400 megs.
No, we can give you a trended time. That's something we can.
Well, are there plans to add that who manages your monitoring? I mean, is,
The Global Knock does, yeah.
okay.
So if that's
Well, how
something
do
that we
put in
can take
enhancement
back,
requests then?
yeah, we can take that back as a
Because we shouldn't
feature
have to
request
ask
for
you
sure.
guys. We should be able to go and look at trending data ourselves, just like we do with the overall
Right.
Yep.
utilization.
So we've got some of our software team out in the hallway here, and we can certainly talk to them. But yeah,
That's great, yeah.
we've got CJ out in the hallway, and he's happy to go over what tools are available to us today. And certainly if there are enhancements to those tools that we'd like to see, we can put in a feature request to do that.
And really, that goes for anything. So, I mean, an advantage you guys have is that you have the ear of the decision makers, right? So the guys who develop the code for our monitoring tools are in the next room. The people who decide what goes on from an iLight perspective are in the same room. So always be vocal about that stuff. And the more we hear, if we hear that request once, we'll put in a feature. If we hear it 10 times, we're going to really hammer away. Guys, we really need this, and it needs to be a priority. So please be vocal and let us know.
So,
Because it's always that, well, how do I know how much commodity I should be buying from you if you're not showing me what it is?
Well,
you're using?
in the short term, if you want a date range, let us know, and we'll give you a snapshot of that date range.
so same issue, little different angle. What I have to go through every year is explain to campus why the costs go up, why we have to buy more. And so what I liked was, I can go out and look at our data and I can look at our growth, but recognizing everybody went up 12%. So I can, why would you expect us to be any different?
Yep.
So the compiled data you showed at the end, which is everybody mushed together, it would be my dance plan for next year. So
Yeah, it's easy to say, hey, from an internet perspective, or just a connection perspective, but on an internet, we only grew 30%. Hey, the rest of iLight grew almost 70. Yeah.
Another question about the caches. I know, at least as of a couple months ago, you had documented on the NOC website what subnets were being used for what caches, and I can't find that anymore. And I also noticed that when I did see it, it looked like it was last updated like maybe 10 years ago, and didn't have things like Apple CDN, which you had up that you now have caching for. So is there updated subnet information for your caches?
What do you mean by updated subnet information?
So the network ranges of what IP addresses are used. So when we see traffic going to these IPs, that is from those IPs, that is your caches.
Sure.
Because we treat that traffic differently.
Yeah, absolutely. We can definitely provide updated lists.
That'd be great. And also, one of the other networks that we see used a lot is Limelight CDN. Do you have any plans that you're allowed to tell us about as far as caching?
I
for
wouldn't
that?
keep any of that secret.
Okay.
So
I didn't know if there was anything that
my
they
goal is to
said
be
while-
really
while we're-
transparent. So
I just
but
know sometimes companies say, while we're negotiating, you can't talk about this. So,
no, really no, but that doesn't mean that's more. I didn't know anything about them.
okay.
So that's,
LLWN, Limelight caches are used a lot by Sony for their games. Microsoft
well,
uses
see,
them
I'm an
a lot.
Xbox guy, so I'm just gonna go ahead and say no
I
right
mean,
off
I'm
the
a PC
bat.
gamer, but
No,
we have
yeah,
to,
that's
we
good
have
to
to deal
know.
with the consoles.
Yeah, I'd say the two that we've been at least the most immediate are Facebook. Especially Facebook's pushing a lot of video now, so it's even more. It's not just pictures anymore. So I think that's right. My wife shares those with me constantly. I wish she would make one of those. Anyway, but she's a great cook, but she sends these ideas. I'm like, that'd be great, and she never makes any of them. So, the other is a Microsoft, and we were in a conversation, and it was a while ago, and a million years of stuff with the upgrades have gone on since then. So my memory's hazy, but I remember kind of dropping the phone when I heard the numbers. So, as far as for a 10 gig peering with it was crazy high. So that's something that will happen. It's just a matter of when.
So who's the right person? Who's the right person to talk to get the updated address ranges?
I'm working on a ticket right now.
Awesome. Thanks.
Yeah, and any of those things, you can just go through the knock and say, hey, I mean, even if it's a feature request, you know, and if it's something where it's, hey, I got a feature request and I don't just want it to fall on any old engineer, you know, you can say, hey, I'd like it to go to Caroline or Christian, or, you know, it'll get our attention put to it. So if that's, as far as standard troubleshooting break fix stuff, that's going to go in the round robin. But something like that where it's a feature request, or, you know, feel free to add some names to the list.
I'm just going to echo what they were saying about asking for the commodity breakdown, and also the IP. We ran into a problem where our Blue Coat firewall treated all the traffic that was Netflix cached as education and said full bandwidth because it said that belongs to an edu, because it looked at the IP address and it got confused. And the other thing, your graph, that big weird drop you have at the very end, is Thanksgiving break.
Oh, there you go. There you go. You would think some of that would go up, but yeah, it's hard to predict. But yeah. Yeah. So that's Thanksgiving, yep. Yep. And it's just, I mean, it's still a decent amount of data when you think nobody's there, you know? I mean, that's still several gigs of sustained traffic, you know? Everybody's hungry.
I'll go ahead and make a ticket to get the more granular.
Yeah.
We'll definitely need contact. I know Bob used to definitely.
Oh, yeah.
I'm sure everybody does, but anybody wants to just come up?
I can kind of explain what's happened over the last few years. We've tried, and Marianne can vouch for me, but it has fallen on deaf ears. So I think we're at the point now where if we can't get movement from the system support, we have Christian and Bill and others that can actually get the information out. We'll just we'll do a hack for the members so we can get this data to them. It's been 3 years. I've been telling them, yes, we're going to get this for you.
Yeah.
So if we could all line up in front of CJ outside and explain to him how important it is, that might help push it through. So.
Well, and this is a squeaky wheel gets the grease thing, and I know you guys have asked for it before, but if we can send a pile of, hey, we've got 10 major that are asking for it today, or, you know, I mean, it's going to be nice to go out and say, hey, they hammered us with this one issue. That helps us get more leverage to make it higher on the priority list. I mean, you know, so please be a squeaky wheel and drive Caroline nuts with it, so we can all laugh as she pounds her fists on. But it will make a difference. It'll, you know, it just goes up the chain.